Hello, everyone. Thanks for joining me here after a series of talks and events throughout the day. My name is Shadi Ashnai. I'm the manager of Sound and Vision, basically working on image, audio, signal, video processing here at Wolfram Research. Let's get started. I've already put in chat. I've put 2 poll questions, not to make it too difficult. If you could kindly take a minute to give us some feedback, whether you have already got started, and if so, what do you wish to see in the upcoming features, upcoming versions, that would be great. In version 12.1, we introduced video as a first-class citizen in the Wolfram language. With that, in addition to the object and basically just a video player, came a few limited number of editing and analysis capabilities. Version 12.2 takes that to a different level, adds a good number of new capabilities by adding functions to generate video, perform additional basic editing, and do filtering and analysis. This talk is basically a demonstration of the current state of video capabilities in the Wolfram language. I will go through the things that had been released earlier in version 12.1 as well, just so that this is a complete status update on what is in. So as I said already in 12.1, we had video object, we had some content extraction, basic editing, and some processing and analysis, as well as programmatic playback. Coming in 12.2, video generation, more editing, more analysis, and in fact, some renames compared to version 12.1 is coming. Towards the end of the talk, throughout the talk, I'll also mention what is up next for us as far as development of video capabilities. There's a question about what version is needed to run this notebook. Yes, a 12.2 version is needed. And a lot of these have been added to the nightly builds of 12.2 very recently. So depending on which version of 12.2 you have, things may or may not be present. All right, let's get started. Video in the Wolfram language is all at a core. So when I have a file like this MP4 sitting somewhere on my file system, I can wrap a video wrapper around it and basically get a representation of the video object in there. If I click on that, by default on all platforms, the video starts in an external player. In my case, on Mac, it is QuickTime Player. There are, however, other type settings for this video object, like this minimal user interface or a basic user interface with some controls to play, change position, change volume, and so forth of the video object. The reason why this is still not the default, and we were hoping 12.2 is going to have one of these views as the default view of the video object, is that we require library link support, which is a technology to communicate data from efficient C++ libraries to our system. We have that connection between Mathematica or Wolfram language kernel to C++ code. We don't yet have that for the front end. That's on top of the list that's coming, and video player is going to be one of the first users of library link support in the front end. So eventually, this is just a prototype of what a video GUI may look like in the future, just a proof of concept. An efficient version of this is going to be coming hopefully in the next big release or release of the Wolfram language. The fact that video is out of core, which means only the amount of data that has to be displayed gets fetched at any time, makes it possible to access video files that are hours long. In this case, I have a video recording of one of Steven's physics live streams, and this is almost a 2-hour video at screen resolution, 25 frames per second. And while I may not be able to play this efficiently in a notebook, However, I'll be able to analyze this just like I'll be able to analyze any other file that I will show in this demo. Okay, support for files that have multiple video audio subtitle tracks are as well in our mind. There are not that many video files that have more than one video and more than one audio track. There are very few that have any subtitle. However, there is applications for this out there, and our design basically goes around the fact that we are aware that this is a possibility. A lot of the containers out there for video content allow for multiple tracks, and as well, our system is ready to take those in. We do have an extensive support for codecs. Here are formats that we support for encoding, and each one of these containers may have data stored in different video codecs or audio codecs or subtitle codecs, and there is a large number of those supported. I would think it's going to be rare if there is a video that we cannot handle. However, a trick is that we are using FFmpeg as a backend, and it's really helping if you install FFmpeg on your machine, because a lot of these codecs are patented, and it's not going to be possible for anyone to have these out of the box readily available to everyone. However, FFmpeg makes all of those available to everyone. So if you install FFmpeg, you can basically get access to more codecs, both for decoding and encoding. And then as well for encoding, which is writing to a file, also there are all common containers or formats. Most common encoders, codecs, are supported for export. Content extraction. A video always contains, as I said, typically a video track and some, potentially most commonly audio tracks as well. So here with the video that we showed earlier, we have one video track, 3 audio, 2 subtitle tracks. And in fact, I may be able to just quickly show how we think we're going to be ready to even display. So if I start playback of this video object, I'll be able to see or see.
Face, crown, flight feathers, and tail are black. Their upper parts are gray.
Other audio tracks, as well as displaying one of the subtitle tracks. So with that, we have functions that can extract frames, video frame list, equally or randomly select or picks some frames out of the video file. And then readily available, you have a suite of image processing that can put these frames together or analyze them in whatever way. There is also video extract frames, which you can give it an explicit time or list of times and just extract data from that time of interest. The audio data stored in the video can also be extracted by simply wrapping audio around the video. This must be a bug in recent in the build I'm using. But assuming this worked, then the spectrogram would simply be a spectrogram of any audio, just as if I've done something like, I actually think this other one may work in this particular build. All right, so that worked. And then with that, I'll be able to just compute something like spectrogram of audio. And in fact, the example I had earlier was if I have a video, this is a not so nice feature. I have a video connected to that MP4 file, and if I extract audio out of it, same thing, spectrogram of audio is going to be the same thing. Okay, track selection. 12.2, so this was not available in 12.1. Video object has these 3 options: video track selection, audio track selection, and subtitle track selection. So my video comes with 6 tracks, 1, 3, and 2 of video, audio, subtitles. And I can say whether I'm interested in having all of them in my video object, and I'm interested in analyzing or processing all of those, or I would like to simply just connect to one or some of those and not all of them. So looking back at the bullfinch video that I showed earlier, this is the video that I showed. However, if I construct my video object with those options, saying I just want to look at the first audio track and I don't care about subtitle tracks, if I construct that video object and get information of that, this basically gives me just the tracks of interest. And the options are also accessible through import, which is something we already had in 12.1. However, as I had up there in the notes, there was a rename in option names from video tracks to video track selection and onward. So make note of that. These are all coming out experimental, and we may change the design along the way just to make sure this is getting to the correct design. Along the same lines, we would like to have a time selection option. The name we have reserved for it so far is video time selection. And for instance, the same video that I showed earlier, the almost 2-hour live stream, I'm just interested in 1.5 minutes of it. And eventually, not in 12.2, I'll be able to say, okay, this is my video, but I'm only interested in that 1.5 minutes of that video. All of these track selection, time selections are happening lazily, which means there is no transcoding happening by setting those options. Those options sit there until you need them. And then if you say, I want to say, do any analysis on that 1.5 minutes, we jump to that time selection specifies and just start processing or analyzing starting from there. Video generation is something we had already started from version 12.1. An example Stephen also showed in the keynote is creating video objects from manipulates. Here, for instance, I have a simple manipulate, one slider, a lot of those on the demonstrations website. And if I just wrap video around this manipulate object, I'll get the video version of this manipulate, which is frame by frame rasterization and export of what you see as you scroll through that slider. And so the one above was a manipulate, the one below is a video object. Now, something that's coming in version 12.2 is generation of video from functions. A function that we are introducing in this version is called video generator. If you simply pass to it one image or a function that creates images with an argument that is time, this shouldn't really take a long time, so I'll go ahead and just create it here. You get a video object again. A video file sits on the file system, and we'll talk about where we store things. And then at the default or specified frame rate, you generate all of those frames and then export it to the specified file. Use cases of this. A lot of times we have 3D objects, whether they're 3D graphics, 3D geometry, or anything else, that we would like to move around so that we see all sides of it. Video generator can simply take these and with any transformation, in this case, I'm defining a simple rotation transform, can basically take this function that goes around or rotates around a 3D object. As it rotates, generates a frame, rasterizes them, puts them into the video file. And right, so these are just 4 frames of the file. In the future, what we have on the pipeline, we almost got it for 12.2, barely missed it release or the freeze we had last week. Recording from the webcam, just like we had current image, which is giving us one image frame from the webcam at a time. We're going to have some function that creates a video from a webcam with some user interface that you're able to start or stop. and definitely a programmatic way of doing that. Recording the screen, just as I'm presenting now, either my whole screen or a specific notebook or a specific bounding box from the screen, we will be able to record. And we really think there is a need for having video sort of consumer-oriented, application-oriented ways of creating videos from for specific needs. Like, as I said, rotating around a 3D object is a very common thing. So we do envision having more high-level, very specific video generator functions in the system coming up either from our team, if they are very generic, or from other teams like the geo team or the graphics team and so forth. Another thing that has been requested a couple of times, manipulate recording with full control over controls of the manipulate. That as well is something that we have talked about it. We haven't really worked on it. However, that's as well, we understand something that a lot of, especially our users, are interested in having. The performance of video generator compared to list animate is a question Michael asked on chat. There is a huge difference between list animate and video generator. When it comes to performance, the problem I see with list animate is that if you have so many frames, if your list is very long and every expression is large, it just simply cannot fit into the notebook. And the notebook becomes bigger, the slider becomes slower to manipulate and so forth. And you can basically just have it for a dedicated amount of time, as opposed to video generator with, as it rasterizes every frames, it writes it to the file. So you can create hours of animations or data as you need. You're not limited to the memory that you have available on your machine or anything. So it's really, I think the biggest difference is between in-core and limited, in-core and I would say a little more efficient and all available in the notebook, or out of core, but with no bounds or limitations on the memory. Programmatic playback, again, something we had already released in version 12.1. Once I have a video object, I can also have a video stream handle connected to that. This video stream has some properties similar to the video object. Things I can do with it. I can actually ask for, let me take this piece out for the time being. I can ask for things like current frame or position. Let me get this one as well going. Dynamically, shouldn't pink box ideally. And then I can say video play. And as I video play, the frame is showing up there. And the position is down here. And what I had there, let me just pause, as I think the video was a bit too loud. What I have there is exactly identical to what we had shown for years as dynamic of some function of current image. So this is really a stream of frames coming now from a file instead of any device. And we connect to that, we can process it as we go, and it's all efficient. Let's move on to video analysis. We all believe, at least around the team, that analysis is going to be our biggest strength when we talk about video in the Wolfram language. The reason for that is that there is a vast number of functions for statistical analysis, machine learning, neural networks, and then visualization, which is typically bundled with all of those when it comes to reporting on any kind of analysis. I think in the future versions as well, we are going to be putting a whole lot more effort on analysis rather than anything else. One of the functions we have released in version 12.1 was video time series. This is now being renamed to video map time series to be more consistent with the other namings that we are picking in the language. Again, I'm linking to a video, video map time series of any function. Now, compared to what we had in version 12.1 called video time series, can take arguments linking to image, audio, or time. And if I run this, it grinds through the data frame by frame, computes, basically reads in image data, computes the mean intensity, and basically goes on. And then we can obviously use any function like date list plot to visualize the result that has come back. As you saw, there is a progress indicator that is being widely used by other teams as well. But since video analysis and video processing is by nature not a very fast operation, we are exhaustively using it around our capabilities. As a separate example, well, I had it pre-computed so that you don't have to wait. What I'm doing, computing a property partitions of frames, for instance, distance between consecutive 2 frames at a time, and then plotting this basically shows when we have frame changes. Video intervals is another function that similarly can take a criteria or a function here and basically gives me intervals for which that given criteria holds true. So here again, we're just grinding the data. I think I'm still waiting on that previous computation to finish. Let me check, or maybe that's already finished. So this one is going. This should as well have a progress indicator. I don't know why it didn't show up. So these are the intervals of interest, which basically comes from that, or is very similar to that first computation I had done. A new function in 12.2, video map list, is very similar to video map time series with the difference that video map list returns a list and doesn't basically have the limitations of time series, which requires consistent dimension data when you have arrays. For instance, we couldn't do, or we can't still do, video map time series of dominant colors. But now with video map list, we can do that. And as I said, here, dominant colors returns lists of different lengths. And lists in the Wolfram language are capable of storing any rank, ragged arrays, and so forth. And with some computation like that, we can flatten the colors, get the tally of those, get the word cloud, and so forth. It's basically enabling more analysis capabilities in our system. In order to analyze video and audio track at the same time, these functions that can be specified in all of these analysis functions that we are adding to the system can take these named slot arguments. So I can do things like video intervals of some mean image measurement times mean audio measurements greater than something. So basically, I'm looking for intervals that I have content both in image and audio tracks. And that's some kind of interval that comes back from that computation. And last in this series, I have image waveform plot and image vector scope plots, which are 2 functions that we basically created as well for version 12.2. The main use of these are in actual video editing for color grading and so forth, or color adjustments. And I'm looking at those dynamically with the stream I created earlier. I'll play this as well, and then you see that these scopes are modified as the stream is played. Okay, video editing. We are introducing video editing capabilities just to make sure people are able to perform editing operations, get the piece of or interval of interest, or do any other operations on those. I'll probably skip through these a little fast, as I don't think I have a whole lot of time left. Video trim, as obvious as it is, trims first part, last part, or a part from the beginning. These are the obvious syntaxes for a function like that. Video delete basically gets rid of or deletes those intervals that are specified. So if you say T1 to T2, it basically deletes that part and joins the before and after. Video split, and by the way, all of these illustrations are from our 12.2 documentation. We believe these are very nice and intuitive and hopefully make understanding our functions a lot easier. So video split with the specification of some times basically splits the video into multiple videos. This is an example. Video join, the obvious things. You have multiple videos, you can join them. Video combine, basically a parallel version of video join. Synchronously, you can add an audio to a video, which is really powerful when you export manipulates to a video file, which ends up being a no sound video. And then you can combine that with any audio and you have it audioized. And then a function video transcode is capable of doing multiple things. You can transcode to a different container. You have an MP3, you want an OGG, you can use video transcode. You have a video that is at 30 frames per second, you want 15. You can do that with video transcode. And some neat thing we're experimenting with is that we're looking at some services like Twitter and Instagram and say, okay, we want a video transcode to that service. Obviously, a lot of these services already transcode as well, but we think it's going to be more efficient if you transcode and then upload it. You're going to be saving some good amount of time. With processing, we already had video frame map in 12.2, in 12.1. And what video frame map does, every frame, you get a processed version of that, exported to a new file, or a partition of video frames. You process them together, put it in the file. Using a video that I can quickly maybe show. It's just a ballet I picked from Pixabay, which is a great place for free video. I can perform things like color convert to grayscale, the obvious thing. I can perform any effect. This is one of my favorites I've used a lot in image processing demos, which basically adds a black line around the edges of the image. Let's quickly show this one. And then as well, we could, okay, so my next example, we do things like I do something called letterboxing, window boxing, where you basically need to comply to specified width and height, but you would like to somehow squeeze your data into it. So I resize to up to 300 in each dimensions and then crop to 300, which is basically padding in this specific case. And using the multi-frame case, I'm taking every 10 frame and then blending the first and last of that, which is somehow showing a blend effect over time of that same video. Video frame map is very similar to, video map is very similar to video frame map with some very subtle differences. The function can take audio and time data in video map, and what comes out is or should be exactly specified in the input. In video frame map, we copy whatever track that is not processed. Video map, you have to specify what you would want in the output file. Audio track apply very quickly, processes the specified audio track, and you can specify which audio track using audio track selection. Okay, I think this is important, so let's take a minute on that. Where are we putting generated files? A lot of you who have played with this know that we start putting files because this video is all at a core. In 12.2, we are introducing an option and a variable, generated asset location. And when I am trimming a file, a video, the 10 seconds of the video, I can specify where I want to put it. And the destination or the location can be a directory or an actual file name with a possibility of saying I would like to overwrite the file. So if you're working on a project, I think it would be really neat to be able to say, my dollar generated asset location is my notebook directory, and I want every asset that gets created along the lines gets placed into that directory. And this doesn't only work with video files or video operations. This is the list of functions in 12.2 that accept the generated asset location option. More of it is going to be coming in the future releases. As I said, a large number of codecs and containers are already supported. FFmpeg installation on your system is going to improve whatever you have out of the box in the Wolfram language, and also your operating system, which we leverage as well. In 12.1.1, we switched some of our defaults for container and codec. We think this is a much better state compared to 12.1. Play with it, give us feedback if it is not. Currently, most functions like video trim preserve container and codec. But again, I guess if this is not really still suitable for some applications, let us know. And we're going to look at this. Next up, as I said, analysis is really on top of our list, and all of us believe that's going to be our strength. So more advanced analysis is going to be up there. Tight integration with neural nets and machine learning, probably the #1 requested feature is net encoders for video, is going to be up next. Efficient player using library link in the front end, I already said that. More generation, more editing, more everything is going to be coming, as most of the team is fully focused on video at this point. Thanks for your time. Sorry I went over time. I'll try to quickly catch up with some questions. However, we have the meetup on video processing tomorrow. I requested an hour. This is an hour and a half. Great. Make sure you're there, because we are really excited to hear feedback from you, suggestions, wish list, anything that you think is going to be worthwhile for us to spend time on, and then make your life easier using Wolfram Language for video computation. We're excited to hear that. Quickly, one question I see on the chat. Video trim will be able to accept seconds. We do accept quantity seconds and quantity frames, or quantity basically any time. You can say 1 minute, 3 seconds as a time specification, or you can give it as a frame specification. So from frame 100 to frame 150. Will Wolfram Language be able to capture streaming videos? Yes, this was one of the things we were working with, IP cameras for sure. Streaming videos, I think some streaming services are basically disabling recording capabilities. We're going to be looking a little more carefully into that, but practically if you're streaming on your screen and recording that, you could basically do that as well. I guess with so many other software, so we're going to be supporting that. Separate different channels, I think that's meant to separate different tracks. We don't have it. However, we can specify the track of interest using the video audio track selection options, and then export specifically the track of interest into an audio or video file. So I guess there is a workaround for that, but we don't have something like we had for images. We had color separate. For audio, we had audio channel separate, I think. We don't have a dedicated function for track separation as of yet. All right, if no other questions, let's hold it here, and Stephen is going to be having another, I guess, event coming up. Thank you very much for joining me again.